morning, ma'am. I am Rakshita. Along with my team members, Pushpa, Usha, Yashaswini, we are present here. We are present our project title, Digital Image Pre-Processing in Fingerprinting using Morphological Tools. Now I will explain the introduction of my project. Mathematical morphology is a very important technique in digital image processing. It provides different operators that help in image and analyzing images. These operators are mainly used for tasks such as edge detection, noise removal, image enhancement, and also segmentation. These operators are mainly used in biometric or binary images where the image contains only two values, black and white. The main morphological operation used are dilution, erosion, opening, and closing. These operations are applied step by step to reconstruct and improve image features, especially the fingerprint pattern. Morphology has a wide range of applications such as medical image analysis, robotics, and visual feedback system. In addition, biometric has become a major field where fingerprint, face, and iris, which means biometric contains the fingerprint, face, and iris, are used for security and authentication. Since fingerprint are unique for every individual, so we improve the quality of the fingerprinting is very important for accurate identification. So in our project, we use the morphological tool to enhance fingerprint image for better recognition and matching. Next, I will explain the problem statement. In our problem statement, fingerprint image captured by scanner often contain noise, broken edge, and uneven thickness, which reduce the accuracy in recognition. So that's why to solve this problem, we use the morphological operations to enhance the fingerprint and improve the overall matching performance. Next topic is objectives. Our main objectives are to study and understand the important fingerprint features such as ridges and minutia points and analyze how to improve them using digital image processing. To use morphological operation like erosion, dilution, opening and closing, remove noise and enhance fingerprint reads clarity. Using this operation, we can remove the noise. To develop a complete processing pipeline, including grayscale conversion, binarization, thinning, and enhancement for better recognition. To segment the fingerprint and extract the region of interest. So that region of interest means we can use only the portion of the fingerprint is used for authentication. The next topic is over to you, Yashaswini AL.
Good afternoon, ma'am.
Yeah, you can continue.
Good afternoon, ma'am. I am Yashaswini. Now I am discussing about literature survey and methodologies. Literature survey. Before starting the project, we reviewed several research projects related to fingerprint recognition because our main aim was to understand existing methods and the improvements needed. Here we include some of the research papers. Some of them are Epstein Nazim Abdul A. Shamiri research paper, Patil and Surlakar research paper, and Raid AI Naimas research paper. Here we use these are the research papers. These are all mainly focused on fingerprint classification. System requirements. Here we use some hardware and software requirements. In hardware requirements, we use any type of basic processor because because our project is not competitively heavy, so we use any type of basic processor, and 4 GB RAM because it is an enough for image processing, and at least 5 to 10 GB free storage because it store datasets and libraries, so we used 5 to 10 GB RAM, and any type of normal monitor because it is we cannot display any special characters, so we use any normal monitors. And software requirements are Windows or Linux operating system, and programming environments like Python or MATLAB, and some of libraries are also we include such as OpenCV and NumPy. Here methodologies method In methodology, I am going to explain about how fingerprint images are processed, and why enhanced is needed, and what are all morphological tools are used. First I am discussed about digital image processing. Digital image processing means using computers to modify, analyze, and process improper images. It is mainly needed in fingerprint project because fingerprint images contain noises, smudges, uneven loading, and distorted results. So for this reason, digital image pre-processing helps to clean the images and highlight the important features and remove unwanted data. So we use a digital image pre-processing. Then fingerprint is made up of ridges and furrows. Ridges means dark raised lines, and furrows means light valley regions. These both forms are unique patterns for every individual. Fingerprint recognitions depends on detecting and minuting points. Two common minutes are used. They are ridge ending and ridge bifurcation. Next, image data enhancement. It is very important because before extracting minutiae in fingerprint must be cleaned and clarified. Here, enhancement is mainly required because raw fingerprint images uh, have problems like noises, blur, partial impressions, and smudges. So we use image data enhancement. It will overcome all these problems, and it makes the ridges distinct and improper contact, and also remove noises and strengthens the ridge flow. So we use image data enhancement. Then role of morphological tools. First, I am explain meaning of morphological processing. Morphological processing uses structuring element and transform parts of the images. Here we use some of the morphological tools. They are dilation, erosion, opening, closing, and gradient. Dilation means adding pixels to the ridges, and it helps to connect small gaps. Erosion means remove small noises, and opening means smoothens the ridge flow, and closing means it closes small holes in the ridges, and gradient means it highlights the ridge edges. These are all morphological tools we included in our project. Next I am hand over to the Pushpa Kesi.
I am Pushpa Kesi. I am discussing about the implementation of this project. In this project, read the image, load the fingerprint image into your programming environment. This can be done using a function like ImageRead. In our program, we use function called ImageRead. In this ImageRead, we have uploaded the image to to upload the image to make the form morphological tools, and it convert to binary. The binary is represented black and white. This process is called binarization. It is a necessary first step for morphological operations. There are so many morphological operations. We are using some of the operations like erosion, dilution, opening, closing, and the combination operation is called gradient. Next, we have seen the output screen. We can see the output screen. This is the final output of our project. I will discuss about the I will discuss about step by step. First is erosion. Erosion is shrink on the foreground object in an image by removing pixels from their boundaries. When we use this, erosion is to remove small white noses or to separate two connected objects. In this erosion, we are thickening the in this erosion we are shrinking the white ridges. We can see the image, the original image. Zoom ಮಾಡು. Zoom ಮಾಡು. In original, the block is denoted ridges and the white is denoted the valleys. We can see in erosion, this is full almost black, but some of there is white. We can see this is erosion from original to erosion. This is enhanced and darkened by original. The role of erosion is noise removal, refinement of ridge structure, separation of merged ridges, processing for skeletonization. Next, dilation. Dilation is a fundamental morphological operation that expands or grows the white regions. We can see the white regions, and it to shrink on the black ridges. It enhances the white ridges. This is white ridges is called valley. In the original image, this is black and white, but in dilation, it is almost white, but in less of black. The white is, we can see the what we can see in white, this is valleys, and what we can see in black, that is ridges. In dilation we are growing the valleys to expand it, to expand this. The role of dilation is connecting the broken ridges, thickening thin or weakened ridges, filling small holes of gaps in dilation, enhancing the contrast between ridges and valleys. Next, opening. In opening, the opening operation is a compound morphological transformation defined as the erosion of an image followed by dilation using the same structure element. In this opening, we are taking the images by erosion from followed by the dilation. We can see in original image this is black and white, but in opening, some of ridges are black, full contrast in black, but some of the light black and some of their white. This is first two, we can see the erosion full the dark black, and we can see some white. This is first is seen with erosion, and the next is seen is dilation. The role of opening is noise removal in a binary fingerprint image, preserving ridge continuity and shape. Preparation for minute extraction. Minute extraction is the ridge ending and ridge bifurcation, enhancing skeletonization result. Next, closing. Closing is the compound formation operation. It is defined by the it is defined as dilation followed by the erosion. In the closing image, we can see some of small difference between the original and the closing. In closing, we can see the white, almost white, and so normally small black ridges. The role of closing is filling small gaps in ridges. That means in the original image, if they are find some of their break or some of loose, the dilation is used to fill up those gaps and the ridges, and it reduces the noise and enhance the structural consistency, improving the skeletonization and the thinning. Next. Next, gradient. Gradient is the difference between a dilation and erosion of an image. In this dilation, original image in black and white, but gradient, this is fully contrast in a white. This is thickening the white images, but in original image the ridges are in black, but in gradient the ridges are in white, and the valleys in the original image, and the gradient in the valleys are black. This is the main difference of original and the gradient. The gradient role is used to ridge edge enhancement. We can see the ridges are enhancing in the gradient, and the minute localization. In this gradient, we can identify the edge ending and edge bifurcation. Bifurcation is meaning that two and three ridges are connecting to one, and improved ridge segmentation and fingerprint control detection. The next topic is hand over to Usha.
Good afternoon, ma'am. I am Usha. Now I am concluding our project. In this project, we focus on how morphological image processing techniques can be applied to the enhanced fingerprinting image. Morphological operations such as erosion, dilation, operation, closing, and gradient act as a powerful tool to improve the quality of fingerprint data before further analysis. These operations help us to achieve the several important improvements. First one, the remove noise and small unwanted artifacts. This means morphological filters are very effective in removing small unwanted artifacts. Second one, enhance right continuity. Fingerprint rigid often get broken due to the poor image quality. Morphological operation help to restore the smooth rigid patterns. Third one, fill gaps and isolate the critical fingerprint features. This helps to fill the gaps and close the isolated important fingerprint features such as mycia, which are essential for identification. Fourth one, actuation the boundaries using the morphological gradient. The morphological gradient highlights the rigid boundaries, making future extraction more accurate. Overall, this enhancement greatly support later step like minutia extraction and fingerprint and classification, which are crucial for biometric authentication system and forensic investigation. Next one, future scope. In this future scope, integration with a deep learning module, morphological operation can be combined with the CNNs to increase the accuracy of the fingerprint recognition. Next, second one is real-time biometric system. Optimize the morphological techniques can be embedded in the low power hardware for real-time fingerprint recognition in smartphone, IoT device, etc. Multimodal biometrics. The same enhancement idea can be extended to the system that use more than one biometric input, like fingerprint plus iris or fingerprint plus face. This includes the reality and security. Fourth one, noise adaptive morphological kernels. Adaptive structuring element based on local image noise level could enhance the processing effectiveness in diverse environmental conditions. Next, application. We highlight where the morphological techniques used for the fingerprint enhancement can be applied in the real world. First one,
Yeah, okay,
integration.
Usha. Yeah, Usha, you can stop here.
Ah,
I have few questions regarding this. So the first question is that why morphological operation is used in fingerprint processing? Is it necessary?
yes, ma'am, it is necessary because in some situation we can deep learning with the fingerprints to recognize. We can use, ma'am, this application.
Like what major thing the morphological operations will do?
Ma'am, for integration with a deep learning model and biometric authentication, we can use these morphological techniques, ma'am.
So the main agenda of a morphological operation is to remove the noise or the fill
Noise and
and fill the
unwanted
gaps. Yeah.
artifacts, ma'am.
Yeah, to extract the feature from the important feature that is there in the fingerprint. It is
Yes, ma'am.
very essential to use it in the fingerprint processing. Okay.
Yes,
So
ma'am.
next is you have used a digital image processing, right? So what is the difference between a digital image processing and an image processing? Like, are they both same?
No, ma'am, digital. Digital and morphological means?
Digital image processing, digital image pre-processing, which you are doing in this project with image processing. Is there any difference?
No, ma'am.
Anybody can answer. It's not
Yes,
Usha.
ma'am. There is a difference, ma'am. Digital image processing and image processing.
What is the difference?
Ma'am, image processing contains only analog images, ma'am. Digital image processing, digital images contain model.
Yeah, that's absolutely correct. Like a digital, it will take the digitalized images like which we use in our system in our computer, whereas image processing, it is mainly focusing on analog images. Okay, so when you're giving a input to your model, uh, should it be a black and white or should it be color also?
Both, ma'am.
Okay, so which process, like fingerprint will be a black and suppose you are giving a color image, but the actual fingerprint analysis which I saw in your result is a black and white. So from the color to the black and white, how it is done? Like
Ma'am,
which
we are
process?
using the binary, ma'am, to convert color image to black and white. So that will become the output in black and white.
Yeah, using binarization, you will convert this into a grayscale image, right?
Yes, ma'am.
Yes, ma'am.
Okay. So what are the pre-processing steps done in the fingerprint image processing? Like what does pre-processing does? Like you have taken a data, like first step is the data collection, that is the raw data which you are taking, which you are giving as input as a fingerprint image. Now what is the pre-processing steps you are doing on that image?
Prepare the image before applying the morphological operation.
Yeah, so what you are doing it?
Its goal is to, ma'am, remove noise,
Yes.
enhance the shape clarity, and convert the image into suitable format, ma'am, like
Yeah.
binary.
Okay. Mm. Mm, mm, mm. So, what challenges can occur in the fingerprint image processing? Like, if we don't do pre-processing, what can happen? If we skip that process, what can happen?
It will
Problems like
problems
causes
like
like
noises,
noises, smudges, and uneven lighting. So for this reason, we have to pre-processing the images. And this helps to clean the images and highlight the important features.
features.
Anyone can answer. What challenges may occur if we don't do the pre-processing step?
Selection of structuring element, ma'am,
What does that
and
mean?
sensitive to noise, and
Like
loss
the
of important
major thing that will be done in your pre-processing step, that it will remove the noise, right?
yes,
So
ma'am, sensitive to noise.
if you skip that step, all the unwanted things will be there in your final output, and detection of the or the accuracy will be less. Correct? Yeah. Okay, then we'll wind up
Yes, ma'am.
this session now.